In this lesson, we'll be learning about series circuits. Taking a look at this diagram, there are multiple components that we need to go over in order to understand series circuits. First, this component is called a battery. The strength of it depends on its voltage. This voltage supplies a current, which flows through the wires to power the resistors. A resistor is any electrical device that is hooked up to the circuit. So it can be a toaster, a blender, or a TV. The current is constantly being circulated throughout the circuit to power all the resistors. But let's say that there was a very weak battery hooked up to the circuit. The resistors attached to it will probably work at a very low efficiency, or may not even work at all. But what if we had the opposite problem, where the battery is way too powerful compared to the resistors? Say we hooked up a light bulb. What would probably happen is it would light up and then instantly burn out. But let's say that there was an equilibrium between the power of the voltage and the resistance of the devices, and that this resistor was a nightlight and this resistor was a microwave. Obviously, the microwave is a lot more complex, so it will put a lot more resistance on the circuit and require a lot more voltage to run compared to the nightlight. Now that we have a little bit of an understanding about series circuits, let's try and solve one. To do that, there will have to be a few given numbers. So let's say that the total voltage is 15 volts, and that these three resistors, R1, R2, and R3, each have respective resistances of 21 ohms, 28 ohms, and 32 ohms. With that information, we can now solve the rest of the circuit. But what variables are we looking for, and how do we solve for them? Well, obviously, there would be a total voltage, a total current, and a total resistance. Based on how many resistors are in the circuit, there's also a current and voltage for each resistor. We know what variables we are looking for, but now how do we solve for them? Well, let's take a look at some of these equations. The first one is Ohm's law. V equals I times R. Voltage equals the current multiplied by the resistance. This formula is universal, meaning it can be used in all three types of circuits, whether it's series, parallel, or mixed. However, there are a lot of formulas in which they are true for one type of circuit, but false for the other type. You see, where series circuits get their name is that all the resistors are all lined up in one continuous path, as they are in series with one another, where the current flows to. However, it's different for a parallel circuit, in which the current splits up and travels on multiple different paths. I will cover parallel circuits in another video, and when it is released, it'll be in the description of this video. Anyways, let me introduce the Kirchhoff laws for series circuits. Those including that the current at one resistor is equal to the current at each of the resistors, which is also equal to the total current. Meaning that if we find one of the currents, we have found all of them. Another formula is that the total voltage is the sum of the voltage at each of the resistors. And finally, very similar to the last formula, the total resistance equals the sum of the resistances from all the resistors. What we can first do is solve for the total resistance, as we have R1, R2, and R3, and so RT equals 21 ohms plus 28 ohms plus 32 ohms to equal a total resistance of 81 ohms. Let's box it to keep it neat, and now plug it in for RT. Now, seeing as we have the total voltage as well as the total resistance, we can now solve for the total current using Ohm's law. And with some rearranging, the current equals the voltage divided by the resistance, which equals 0.19 amps, rounding to two significant digits. Just to clear up some confusion, for Ohm's law, you cannot use V1 and I2 to find R3. No, you must use two values in the same row to solve for the missing one. Now, remembering this formula, that each of the currents are equal to each other, that means that we can plug in 0.19 amps for each of the other currents. But to show our work, we need to show that IT equals I1 equals I2 equals I3, which equals 0.19 amps, to get full marks. Now look at that. We have all of the currents as well as all the resistances, and now we just need to find the three voltages. And so V1, V2, V3 each equal 0.19 amps, times 21 ohms times 28 ohms times 32 ohms, which equal 4.0 volts, 5.3 volts, and 6.1 volts, rounding to two significant digits. These numbers are probably right, but there is a good way to confirm recalling this formula, and so Vt equals 4.0 volts plus 5.3 volts plus 6.1 volts, which equals 15 volts when we round to two significant digits. And now the circuit is completely solved, and we have showed all of our work. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.